Everyone, and welcome to this breakout session, Finding Needles in the Haystack. My name is Tali Ash. I'm a product manager for the Azure ATP team.
Hey, Tali. Ooh, you need to turn it a bit lower. Yes, thank you very much. Hi, Tali. And my name is Eyal Manor, and I'm coming from the Azure ATP team as well. We're building the Azure ATP product for the last 2 years. But today's session is not just about Azure ATP. It's about the investigation experience. It's about security operations experience, or as we are calling it, how we can find the needle in the haystack. So we're not going to talk specifically about Azure ATP, but about also activities coming from Cloud App Security, Azure AD Identity Protection, and probably later on other solutions as well. It's going to be a very innovative solution because what we are going to show you is super new. Those are elements that we've been working on super hard and very intensively with many of you here in the audience for the past several months already. It finds super interesting items and gives a lot of new observations to our customers and really bring a lot of value. And I think that today this is the first time that we are talking about it in general availability, and we're very happy. So I really hope that you're going to find it super beneficial and interesting, and let us think a bit about how we're doing security operations. And here all of my animation ruined. So one intro slide, it's about users, it's about Tali, and it's about me, and it's about each and every one of you here. We are the new perimeter, and we are the new perimeter because we are the people who are accessing to resources and to applications in the cloud, in on-prem, from many devices, for mobile and laptops and desktops and everywhere. And we know that, and we see that. It's enough to have one compromised user in the organization in order to break the entire organization down. And this is happening because of lateral movements, because that usually the attackers don't care about Eyal. They care about some data or some assets, or to do some violating maybe some of the critical, or not the critical, but the infrastructure that we're having in the organization. So they start by compromising just one identity, and they start moving laterally into another device and another user, and so on and so forth, until they get what they are looking for: privileged accounts, high-value assets, sensitive data, domain controller, Azure Active Directory certificates. All of that would be great for the attackers. Now, let's think about security operations people. We're dealing a lot with security operation people, either tier 1, tier 2, tier 3 analysts, also hunters. And we're thinking all about that. There are several interesting gaps for security analysts who are trying to understand what happened. One gap that security analysts on tier 1 and tier 2 are having many times is, how do we investigate a specific incident where there are dozens or many even more related entities? So it means that there are many, many related entities to a specific incident, and we don't really know how the attacker is actually moving throughout the organization, how they are moving laterally. And because of the number of related entities that we're having, it's not optimized, so we cannot manage them all. If we're thinking about researchers or about hunters, think about all of the activities that we are collecting, all of the user activities. Every time I'm doing interactive logon, any resource access, anytime I'm logging into a cloud application, anytime I download a piece of file from SharePoint Online or from Dropbox, this activity is being logged on. And the hunters are sitting there. They would like to come with their hypothesis, but where do they start? So let's make that a reality and understand how it looks in the SecOps day to day. See this interesting alert coming from Azure ATP. And why this is interesting? Because this alert talks about suspected brute force attack. So what do we see here? We see that there is a related computer. We can see it in the middle. The name of the computer is Jeff DSK, Jeff Desktop. And we know that an actor has been working from Jeff Desktop and started to log in on behalf of many entities. At the end of the day, Azure ATP have identified more than 40, actually 44 accounts that have been authenticated successfully. Now, let's think about sec admins and about security operations. So for the work of the sec admins, the work is very clear. I need to go 44 times, and maybe reset password or something like that, and I'm done. And from the SEC administrators, the work is a bit more complex right now, because what should we do? Should I go at like 44 different accounts right now and see whether the attackers was using them or not? And if not, it's great. And if yes, did they now move laterally and continue? And now it's not 44 accounts, maybe it's like 440 accounts that got compromised in the outer ring, and more and more and more. This will be possible, but it will take a lot of time and it will not be optimized. Let's take a look at another example. I'm SecOps. I'm super busy. I don't have a lot of people. I do have a lot of alerts. And here on September 24th, I got 2 alerts. Impossible travel from Rana and impossible travel for Raj. I don't have time to work with both of them. What should I do? How to optimize that as well? Good question. By time? By what? So this is an interesting question as well. Last example, but by far not the least example, let's talk a bit about lateral movements. So Azure ATP provides us today activity logs when we're identifying a potential lateral movement path within the organization, something that we would like to investigate and would like to leverage. So let's take a look at this interesting activity that we see here. The user in the middle, Beverly. Beverly is a sensitive user. And Azure ATP have identified several dozens, actually 32 accounts and 18 devices that may put Beverly, our sensitive user, at risk. Now, what does it mean? Should I need to go at each and every one of those 32 accounts and understand whether something's wrong with them? Maybe. The question again is how effective it will be. And we've been working super hard, our teams of developers and engineers and data scientists and machine learning people, and many of the customers that we're having here that have been helping us over the course of the last year to help and give you the ability to understand how we can actually prioritize users to investigate. And this is going to be most of our sessions today. So we're introducing today, in general availability, a new concept named user investigation priority. And since we would like to be responsible and would like to have this user investigation priority super meaningful for you, let's understand what does it mean. So first, from the right to left, let's think about the user context. Let's understand how it is the impact of a specific related entity, which is a user, on the organization. Whether the impact of the user is high, whether the impact of the user is not that high. Maybe Azure AD can tell us that this user is compromised through leaked credentials, for example. This is going to be an interesting factor. Not less interesting factor, the number of suspicious activities. And this is something brand new that we are doing today in Azure ATP, in Cloud App Security, in Azure AD. We are profiling each and every one of the user activities and trying to understand what's the probability that a compromised users or insider threat will take a specific activity and will be scoring that. And the third one will be the alerts. The alerts would be those high confidence elements that we can say for sure. This is, for example, a brute force attack, or a DC sync, or an impossible travel, or leaked credentials. So alerts, of course, are high confidence and they will have a lot of impact on the investigation priority. We're not going to talk about them today. You are invited to listen back to BRK2127 from yesterday, earlier today, in order to learn more about our alerts. So what does investigation priority mean? How does it look like? It's simple. It's just a number. In this case, it's 127. The higher investigation priority gets, it means that the more suspicious the user become. So we are at SecOps need to pay more attention to a specific user. And if you're zooming a bit out from the 127 and looking at the entire screen, we can see here a different example, a different user. For this user, the score is close to 800. And we can see a bit more information about the context. Who is the user? Why this user is important or why less? Of course, when talking about important, talking about the potential impact from security perspective, just for us to be in the same terminology. Talking about suspicious activities and alerts that are providing the evidence for the user investigation priority. Make sense? Let's zoom even more out. So we talked about one user and the evidence for the user. Let's now talk about all of the users in the organization. I'm a hunter, and I can zoom out and take a look at all of the users that I know in the organization and ask the system, show me all of the users based on their investigation priority. I can look at the entire organization, or I can filter it to finance, to people in Paris, to people who are connecting to high-value assets, or just to everybody else. And as a hunter, it gives me some hints about what I should do next. So this is super interesting. And let's now go back to the first example that we've seen a few moments ago. So we talked about this brute force attack. And we know that somebody, an actor on Jeff DSK, has been compromised 44 identities. Security operations have already done what they need to do. They already reset their passwords and everything is done. But we still don't have a clue about what's the scope of breach. So if we just click on these 44 identities, we will see that those are actually sorted by the investigation priority. So now I don't need to investigate 44 people. I can investigate the top 1, or maybe the top 3, and rest assured that the other 41 users have been remediated already, no damage is done, no harm is done, and I continue with my life to the next incident. We are going to see that in the demo in a bit bigger screen, better resolution, so you'll see by far more about it. Now, I talked a bit about responsibility. Let's make sure we didn't come to do more work to security operations. The idea is to do less work to security operations. So we don't want you to chase and run after each scored activity. It doesn't make sense. And we also want you to don't look about every user in the organization. We've built the algorithm in a way that most of the user investigation priority scores will be in the bottom 1%. And only few users, it could be a small number, it could be few dozens, depends on the organization size, but it's not going to be hundreds, will be on the right side of the scale of the investigation priority score. This is an example of an organization of more than 200,000 employees. Most of the users, it's like 99.999% of the organization, had a score of less than 30, and then all the way till 1,000 or 800 and something like that, there were a very small number of users, maybe just a couple of dozens, and that would be it. So we talked about alerts, we talked about suspicious activities, and we talked about user impact. These are the 3 big factors that are helping us compose the investigation priority, right? So let's talk about how we're doing that, and let's talk a bit about suspicious activities. First, let's make clear, suspicious activities are not an alert. If we find at Azure ATP, Cloud App Security, Azure AD, we find an activity which is suspicious, we're not looking for you to monitor or to trigger any activity based on that. The idea is that you treat that as a low fidelity signal, but the good thing is that if you're having a very large number of different suspicious activities for a specific user, then the entire investigation priority goes up. And then all of those small number of information become to something which is now significant and has a lot of value. What are we doing in terms of those suspicious activities? We are profiling users. What do we mean by profiling users? It means that we will build a profile for any user. And for any users, we are going also to look at the peers. And we're also going to look at the entire organization and score each and every one of those user activities. For example, logging to devices, or logging to on-premises resources, or doing remote connections, or just signing into a cloud application. We will understand exactly how the user behaves. And let me show you an example. The example talks, for example, about Tali, who is accessing the finance server. First check that we are going to do is to understand how popular the finance server is at the organization. Think about it. If the finance server is super popular, there's nothing interesting for people who are going to the server, right? It doesn't make any sense. So we'll be looking at that, following by understanding whether the very first time that Tali is accessing to the finance server, or maybe Tali has a pattern that is usually let her accessing many new servers at once. For example, maybe she has some service accounts, or maybe she is some help desk person that is doing many remote desktops helping people. So we will learn her behavior. That will be followed by understanding the user peers. And I think that here comes the secret sauce, the user peers. Because think about Tali. She never accessed the finance server, and tomorrow morning she will access the finance server. But maybe we don't know that Tali also moving to finance tomorrow. So if Tali is moving to finance, and her new peers are accessing a lot to the finance server, we don't need to score this activity. And by that, again, we're making sure that what we are scoring is under our responsibility, really to look after those suspicious activities. So this is super interesting. It's working very well. I can tell you that there are many organizations right now that are already filtering throughout activities with high scores and finding compromised accounts, insider threat, where no alert would have the ability to understand that something has happened because there is no logic that we can think about any alerts in advance. So this is super interesting. And this is coming together with the user impact. So let's understand what's the user impact. What if the system would have come and tell you that for a specific user, this is their position in the organizational tree. And these are the number of these people is managing, and these are the number of people in the same level, all of that coming from Azure AD, and later also from Active Directory. And these are the people who are managing privileges in the Active Directory or Azure Active Directory. They have specific privileges that are making them sensitive. And a bit later on, these are the people who are accessing high-value assets, or these are the people who are just accessing sensitive data because of Azure Information Protection. All of this information can give us a lot of understanding of how we can handle this user and what does it mean. And now let's go back to the second example from the previous part of the presentation. So we talked about these two identical twins in possible travel activities, but now we have something better in mind. Now we know that Raj, the one on the bottom part, is managing a group of users, and the role is security admins, and they're accessing a lot of value assets, but Roana is a company contractor, and they doesn't have any privileges that are important for us. Now it makes sense, right? So we know that we are going to investigate the second one, and maybe the first alert maybe will be investigated later. Maybe we'll take an action without even investigating that. Again, the sky is the limit of how we can make that beneficial in order to make our security operation experience by far better. So we're talking here about many interesting things about investigation priority, suspicious activities, alerts, and user impact. Let's take a deeper dive and do some interesting demonstrations about how all of that is looking in reality. And then we are going to have some time to take some questions from you. So Tali, let's see a bit of how does it working.
Thank you. So let's start with the first demo of how you can prioritize users to investigate and respond. We are looking at Cloud App Security Portal because this is your place to investigate identities across cloud and on-premise. In the last year, we were working very, very hard in unifying all the different identity security products into one place. So let's search for an alert with many, many users. We can actually search for the brute force alert we just saw in the presentation. So we can see here two brute force attacks. Let's take the one with the 44 suspect accounts. So you're looking at a brute force attack where 44 users were exposed. And you will ask yourself, which user should I investigate first? Who is the most important to investigate? And for that, you can click easily on the 44 suspect accounts. You will get a full list of all the different users. And for each user, you will see the number of open alerts and the investigation priority. This list is sorted by investigation priority. So the first user to investigate is at the top. We can see here that this is Daisy. Now you will ask yourself, who is Daisy? What is her role in the organization? What is she doing? Is she doing other suspicious activities? She already was exposed in a brute force attack. You would like to investigate her. And I know analysts. At this point, most of the time, they will go to other tools to understand who is the user. They will go to the organizational directory data to get a better understanding of Daisy. But we don't want you to go anywhere. We want to provide you all the information you need to know about the user inside this portal. So what you can do is just clicking on Daisy, and you will be directed to Daisy user page inside this portal. We can see right away that Daisy is a software engineer in the Arato department. And now you would like to understand first who is Daisy, and then what is her risk, why she has such investigation priority of 251. So let's get a better understanding of who is Daisy. In the user threat section, you will see the investigation priority number and also the identity risk level of Daisy inside Azure AD Identity Protection. We can see that she is in a medium risk level. In addition, you can see the number of open alerts that Daisy had. This is 7 medium open alerts. In the user exposure section, you can see different statistics we are collecting about Daisy from the cloud and on-premise. You can understand which assets she's using on a regular basis, like the locations she's authenticating from to the organization, the devices she's logged into, and the on-premise resources she's accessing. You can click on the 3 devices to get a list of the devices she was logged into, and for each device, you can see the last time she logged into this specific device. The last section here is the contact information. You can see Daisy email, phone, and office location. So now we have a better understanding of who is Daisy, and we would like to know why she has such high investigation priority. So first of all, we can see the investigation priority distribution, the number of alerts and risky activities, the suspicious activities Eyal just talked about, that contributed to an investigation priority. At the right, you can see what is the location of Daisy inside the organization. Where is she located compared to all the other users from the investigation priority perspective? Below, you can see the trend of the investigation priority for this specific user. You can see the investigation priority for Daisy in the last 14 days. Each column that is red represents that at this specific day, Daisy was in the top 90 percentile. She was one of the top users to investigate. Now let's get to the most interesting part, to the timeline. In the timeline, you can see all the different alerts and suspicious activities that Daisy had that contributed to the investigation priority in the last 7 days. We can see different risky sign-in from anonymous IP address alerts and some activities on SharePoint and Active Directory. Let's start from this logon activity that is coming from Active Directory from Azure ATP. We can see here that the logon activity was to the RDP server, and it tagged a suspicious activity and got a score of 5. And you would like to understand why it got scored. You can click on the +5 and get evidence why Azure ATP identified this specific activity as suspicious. We can see that this is the first time Daisy accessed the RDP server, and only one other user in the organization accessed this specific device in the last 7 days. Let's look at another example of cloud activity, accessing file in SharePoint. It got a score of +3. Again, we can click on the +3 to get evidence, and as you can see, it's a different evidence. We give for each suspicious activity the evidence that was tagging it as suspicious. So this is the first time the Daisy connected from this ISP, and only 2 other users connected from this ISP in the last 7 days. In addition to that, only 3 other users in the organization accessed this SharePoint site in the last 7 days. So from the user page here, we can understand who is Daisy. We saw that she has some suspicious activities. She was exposed in a brute force attack, and she has some alerts from risky sign-in connecting from anonymous IP. We can conclude that Daisy is compromised. And now you would like to take action. We saw here that the identity risk level for Daisy is medium. What you would like to do is change the risk level of Daisy to high, so all the conditional access policies you configured in Azure AD Identity Protection will apply on Daisy. Again, we don't want you to go anywhere. You can easily do it from this portal. You can go to the user actions and choose Confirm User Compromised. Once we will do that, the risk level of Daisy will be changed from medium to high. It will take a couple of minutes. We'll get back to it later. So we started from an alert with many users, and we concluded that we need to investigate Daisy first because she has the high investigation priority in this specific alert. We understood that who is Daisy, and she has more additional suspicious activities that she was done. So we took action and remediated this specific user. But maybe Daisy is putting at risk other users in the organization. Maybe there are additional identities we should now start investigating. Exactly for that, we are giving you the sensitive users at risk that are at risk because of Daisy through a potential lateral movement path. Azure ATP is calculating for sensitive accounts in the organization a potential lateral movement path. You can manually tag accounts as sensitive, and we also tag for you accounts as sensitive if they are part of groups with high privileges. And for each sensitive account, we're calculating such path. We can click on this number here, and we can see that she's putting at risk two different users, main admin and Nick. Let's understand exactly what is this potential lateral movement path. We are now in Nick user page. We can immediately see that Nick is an admin in the organization, and it has a sensitive tag. For each sensitive account in the organization, you will see in the user page a tab of lateral movement path. You can clearly understand that from Daisy, you can go to Jeff and you can go to Nick, who is high privileges and have access to your sensitive data in the organization. But you will ask yourself, how is it possible? You can hover the device to understand that. We can see that Daisy is a local admin on victim PC. And Jeff is logged into victim PC. It means that once Daisy is compromised, the attacker can get her credentials and logged into victim PC. And because Daisy is local admin on victim PC, the attacker can extract Jeff's credentials, and now, boom, we compromised another account. Let's understand the second hope. Once the attacker has Jeff's credentials, we can see that Jeff is an admin on SharePoint server, which Nick is logged into. So they can use Jeff's credentials to access the SharePoint server and extract the credentials. And this is game over. At this point, they have your higher privileged account, and they can access to your sensitive data. And I said a couple of times that this is a potential lateral movement path. But once one of the entities inside the path is compromised, maybe this path is not potential anymore. This path can help you, the security analyst, to understand who you should investigate next. What is the next step you should take after you remediate the first user, for example, Daisy? So if I was a security analyst, I think that the next step I was taking is to investigate Nick, because he's the most prioritized to investigate. He's my sensitive account. I don't want to attacker get to Nick. So what we saw in the first demo is how you can use the investigation priority to investigate an alert with many users and understand who you should start investigating. Then we saw how you can understand the investigation priority, learn who is the user, and understand the suspicious activities, and actually take action and respond. Then we looked at the lateral movement path and how you can use it to understand your next step and which other identities you should investigate. Let's move to the second demo, how you can hunt over users with the investigation priority. We'll now go to the user and accounts page inside Cloud App Security. Let's wear the hunter's hat of the analyst tier 3. They are hunting for so many users and so many data sources, and we would like to help them understand what is more prioritized to investigate and on which anomalies they should focus on and on which users they should focus on. So we'll try to look for suspicious activities or users that are at risk from our administrator group. So let's filter for the Office 365 administrators group. We can see for each user its investigation priority. So I will sort this list by investigation priority to see who are the top users I should investigate. I can see here admin, Lydia, Nick. Let's look at Lydia. She has an investigation priority which is high enough. You would like to understand why she got this investigation priority and see which activities she was doing in the network. You can see all the activities Lydia was done by viewing her related activities. You will be directed to the activity log filtered by Lydia. And again, in this activity log, you will see all the activities that Lydia made in the cloud and in the on-premise network. We can see different resource access activities, logon, Active Directory activities. She was accessing Microsoft SharePoint files. So many activities, but again, you would like to focus on the important one to investigate. What is suspicious? You can easily do it by filtering for investigation priority. Now we will get all the activities that got scored and contributed to Lydia investigation priority. Again, we can see different activities across cloud and on-premise. You can open the activities. Here we can see a logon to the RDP server. You can click on the +2 again to get the evidence of why this activity is suspicious. You can see the evidence for each activity that got scored by just clicking on the number and you will get the right evidence. So we saw that Lydia was in the top list of users to investigate in our administrator team. We would like to get a better understanding of who is Lydia and to understand maybe she has some alerts and more activities we should look at. Therefore, we can search for Lydia and again go to the user page where you can find all the information you need about this user. We can see right away that Lydia is a software engineer in our auto department. And Lydia is also tagged as sensitive, which makes sense because we started with the administrator in Office 365. Again, you will see her investigation priority and the distribution of alerts and risky activity. And in this timeline, we will see all the suspicious activities and alerts she was doing. We saw the suspicious activities in the activity log, but here we can see also the alert. We see a risky sign-in from an anonymous IP address, suspicious inbox forwarding rule that was set on her own inbox. Then there are some suspicious activities, viewing files, downloading files, and there we have an alert of mass downloads. Everything here looks very, very weird. This is a typical sequence of suspicious activities and alerts that might lead to the understanding that Lydia is an insider threat. And maybe she's not an insider threat, but she's a compromised user. We give you all the evidence you need to better understand who is Lydia, what is the risky activities she was doing, and alerts. Again, once you get to the understanding that Lydia is compromised or she's an insider threat, you can take action and mark Lydia as compromised in Azure AD identity protection make her risk too high.
Isn't that amazing? So we really see how the investigation priority, the scored activities, the user impact can really guide us throughout our work when we are investigating an incident, when we want to understand how to move next, what would be the next hope that the attackers are thinking about, and really shrink the number from a large dozens or maybe even hundreds of entities into one and really guide us throughout the experience. It's really, really amazing. So we have a few moments before we continue to the taking actions part and do a couple of more things that we'd like to share with you. Is there any question from the audience? Anything? Yes, sir. You're the first one.
So the impossible travel I found.
I will repeat your question.
So the impossible travel scenario.
Yep.
I mean, I look in the dashboard, and it's literally the number one thing that shows up all the time for everybody. And if I consider even me being here right now, I've been generating impossible travel alerts all day because one end of this building has an ISP that terminates in Las Vegas, another one has somewhere that terminates in the West Coast, and I walk outside and disconnect from the Wi-Fi, and I'm now in Orlando.
Mm-hmm.
So in the span of like a few minutes, I've moved several thousand miles.
Yeah.
How does it, like, is it, you know, how do we keep this quiet? 'Cause that's
Okay.
really, really noisy.
I will repeat the question and we'll give a short answer for that, and we will not detail that a lot today. The question is about the quality level of the alert named impossible travel. And we will say that this alert is coming from our colleagues at the Microsoft Cloud App Security and from the Azure AD Identity Protection. We can say that this alert has a lot of sophistication in one side, but also have a lot of obstacles on the other side because of different ISPs and anonymizers and VPN connections. So this is maybe one of the most beneficial alerts on one side, but also challenging from the other. We're doing a lot of work to improve that and to make it by far better. Since both Tali and I do not represent a very specific team who is taking the responsibility for that, I will not have enough details to tell you exactly how it's being solved, but thank you for this information. We are familiar with it and working very hard in order to make it better. So I appreciate that. We have time for just one more question, so yes, sir. And after that, Tali and I can be here, because we also want to summarize this session. Sir, yes?
Just a quick one. How long does it keep the logs for?
How long we're keeping the logs for? So the logs for the activities are usually kept for 180 days. And you can use other solutions, such as, for example, our SIEM connector to Sentinel or to other SIEMs in order to make the retention period a bit longer. But 180 days, this is the default. So let's summarize a bit and continue a bit further. And we'll also skip this part. What we can see here is that what we're doing with investigation priority and everything that you have just seen is actually being leveraged, as Tali have showed you over this super amazing demo. It's all leveraged by the Cloud App Security console. Now, it doesn't mean that you need to use Cloud App Security. It doesn't mean that you have to license and to work with Cloud App Security. Technically, each of the solutions that we can see here, Azure ATP is building scores and looking at user impacts for on-prem activities. Microsoft Cloud App Security and Azure AD Identity Protection is scoring activities from the cloud. So if you are a customer that is working just with MCAS, you will have priorities and suspicious activities for the cloud activities. Vice versa for Azure ATP, and of course that we're having the better together, but you don't need to work with all of the three. It will be better for you to have all three, but you don't need to have all of them in order to enjoy of them together. If you're working with Azure ATP, we really encourage you, and we talked a lot about that in BRK2127. We really encourage you to start working and onboarding your alerts and activities into the Cloud App Security and really start enjoying from those core activities, from the hunting experience, and also from a new, super interesting prevention capabilities that we give under the hat of security posture assessments. Again, we talked a lot about that a bit before as well. And in order to onboard your Azure ATP signals, events, and alerts, all you need to do is to go to portal.cloudappsecurity.com. Again, whether you're using that today or not, go to settings, find the Azure ATP during the settings in the left, and just onboard to that. So I really, really hope and sure that you're going to enjoy from this experience. We're having a mailing list that we are monitoring every time, every day, every hour. Feel free, if you have further questions, to contact us. It's aatpfeedback@microsoft.com. Feel free to work with us. So we are like 4 minutes ahead of time, which is nice for you because this is the last session. If you have any questions, you can come by and ask us personally. We'd like to thank you for your time and hope it was beneficial for you. Thank you.